Welcome to Prince Math Clinic, the e-learning solution at your pace and time.
Good day and welcome once again to class. As you can see on the board, today we shall be dealing with Herculean geometry. Before we go right into the question, I would first of all like to explain to us what geometry entails. Geometry is that branch of mathematics concerned with the properties and relations of points, lines, surfaces, solids, and higher dimensional analogues. I'm going to take that again. Say that geometry is that branch of mathematics that deals with the properties and relations of points, lines, surfaces, solids, and higher dimensional analogues. So in other words, geometry in mathematics talks about shape, and anywhere you see shape, you should remember geometry. We have line geometry, we have circle geometry, etc. And today we shall be dealing with this part of Herculean geometry. You can see from the board that we're asked to calculate the value of x in this particular diagram. And to deal with this question number 1, let's expand what we have here. I'm going to explain the concept of when you have two parallel lines and you have a transversal line running across it. These lines are called parallel lines because if you extend them further, the two lines further, they cannot meet. Therefore, once you establish that the two lines cannot meet, it means that if I have this angle here called A, my A here and my B here are vertically opposite angles. Good. Then if I have an angle C here, my angle B and my angle C are said to be alternate angles. Good. Then if I have an angle C here and another angle A here, these two angles A and C are corresponding angles. That is, this angle and this angle are corresponding angles. Now, having known that, in solving this, permit me to extend this line backwards. This is a straight line. If I add angle P plus Q, I am going to get 180 degrees because they are on the same straight line. So therefore, permit me to call this angle A. Then I'm going to label here angle B. Then I'm going to label here angle C. Now, watch out what I'm about to achieve with this. Now, we have said that this and this are on the same straight line. Therefore, they will add up to give us 180 degrees. And I've told you before now that angle R and Q are alternate. So therefore, they are equal. And I've also established the fact to you that what R and T are vertically opposite. Therefore, they are equal. So using that principle, I know that my A plus 115 degrees should give me 180 degrees. Reason, you must state the reason. The reason is very important in geometry. They are angles on a straight line. Now, therefore, if I subtract 115 from both sides, I'm going to get A to be 65 degrees. So, and if A is 65 degrees, and I've said A and B are what? Alternate, it then means that my B is equals to A, and A is what? 65 degrees. They are what? They are all alternate angles. And I've also told you that C and B are what? Are vertically opposite angle. So C is equal to B is equals to 65 degrees again, which is what? Vertically opposite what? Angles. So therefore, coming back to this triangle, now if I add x plus y I will get z. And why is it like that? There's a theorem that states that the exterior angle, which is this z, is equal to the sum of the what? Opposite interior angles. The opposite interior angles in this case are x and y. That is, if I add x plus y, I'm going to get z. So coming back to this shape now, my x is here. So I know that my x is equal to what? C plus 35. That's the reason is that exterior angles equal sum of opposite interior angles. Hence, my x, our C, we have found C to be 65, then plus 35. So it means that if you add 65 plus 35, you are going to get 100 degrees. So hence, our what? The value for x that fits into this diagram is simply what? 100 degrees. Now, let's try to approach the second question. With the diagram we have on the board, again, this is another straight line. Therefore, this angle here and this angle should give me 180 degrees. So, I don't want to label this angle. So, I know that for me to get this angle, I need to subtract this 5y from 180 degrees, since the both of them adds up to give us 180 degrees. The only way to get this angle is to subtract this particular angle from 180 degrees. So, I'm going to write here 180 degrees minus 5y. Then plus, then this angle here, 136 degrees, I'm going to write it. Then plus, then the same thing, this angle here, 3y degrees, and this angle adds up to give us 180 degrees. And so to get this angle here, I have to subtract this 3y degree from 180 degrees. So this gives us another 180 degrees minus 3y degrees. And everything sums up to become 360 degrees. Now, the reason for this adding up to 360 degrees is that angles within intersecting lines within parallel lines. You can see these lines are parallel lines. All the angles that I added here, everything must give me what? 360 degrees. And if I add 180 to 180, I'll get 360 degrees. Then minus 5y minus 3y will give me what? Minus 8y. Then I have a what? 36 degrees here. Everything equal to 360 degrees. Now, if I move 360 degrees to this place, it will be 360 minus 360, which will give me what? 0. So therefore, minus 8y plus 136 degrees will give me what? 0. So it then means that minus 8y. If I move plus 136 to this point, it becomes minus 136 degrees. So therefore, minus will cancel minus. And here, if I divide both sides by 8, 8 will cancel 8. 8 can go in 13 one time, remainder 5, and 8 in 56 is simply 7. So therefore, the value of y is 17 degrees. And with that, we've come to the end of today's class. If the video was helpful, kindly give it a thumbs up, like this video, and comment on the video. And together, we'll all enjoy simplified maths. Bye for now.